Hi, grade 10s. So today we are continuing our study of trigonometry, and we're looking at how we can solve problems that involve right-angled triangles in the real world. So the first video taught you how to use sine, cos, and tan to solve for unknown side lengths and unknown angles. And today we're going to be using trigonometry within a real life context. So anywhere where right angles appear in the real world, we can use SOHCAHTOA. So just a refresher, SOHCAHTOA stands for sine being opposite over hypotenuse, cos meaning adjacent over hypotenuse, and tan being opposite over adjacent. So the same steps that we use to solve for an unknown side length or an unknown angle are true here. We just will be learning some different applications and a few more definitions that will help you. So our learning goals are, first of all, to discover the meaning of an angle of depression and an angle of elevation, to create accurate sketches based on written descriptions involving triangles, and then to use trigonometry to solve problems, as I mentioned. So many professionals use right angles to solve problems. Okay, the terms angle of elevation, get my pen here, angle of elevation and angle of depression are used to help visualize situations. Okay, so if let's say there's somebody that's on the ground and they say the angle of the elevation to the top of the house. So what they're talking about is if you drew a line from here to here, okay, the angle of elevation would be this angle here. Okay, this here is the angle of elevation. So it's the angle between the ground and whatever pitch you're looking at there. Okay, so when you think of angle of elevation, think up from the ground. Okay, now angle of elevation is a bit simpler. The angle of depression is a bit trickier to visualize. So imagine that you're looking from the cliff down to the ground. So like there's somebody standing on top of the cliff and they're looking at an object down here on the ground and they're saying the angle of depression is whatever it is. So if that's their line of sight, most people think that the angle of depression is here, but it's not there. Okay, the angle of depression is made with the horizon. So the angle of depression is here. And using the Z pattern, that means that that's the same as this angle. So this is the angle of depression. So you have to think about it as the amount that they're looking down from the horizontal. So we call this thing here the horizontal. Okay, so you think down from the horizontal. Think down from horizontal. Okay, so it's not the distance from the vertical, it's down from the horizontal. And then using the Z pattern, that's the same as this angle there. Okay, so now that we know those definitions, we can go through and do some examples. So a bridge is being built across a river. A surveyor uses a 1.2 meter transit above the ground. An assistant holds a 3-meter pole across the river. The angle of elevation from the transit to the top of the pole is 8.5, and that should say degrees there, 8.5 degrees. How wide is the river? Okay, so here's the river. And on one side is a transit, which is basically just one of those things that if you ever are driving on the highway and you see those guys measuring stuff, it's just those things with a radar on the top. So this transit is 1.2 meters high. And then on the opposite side, there is a pole that is 3 meters high. So it should look about, just about twice as big. And they say that the angle of elevation from the transit to the top of the pole is 8.5 degrees. So from this to the top, so they're looking at that angle, this angle of elevation. So angle of elevation is always against, like a horizontal. So you wouldn't include this huge big angle here. You would complete the right triangle. And this angle here is 8.5 degrees, where this is a right triangle. Okay, so they want to know how wide is the river. So that would be the width of this bottom of the triangle. Okay, so we know this angle and we know this side length. Okay, the side length isn't 3 though. You have to be a bit careful because this side length here is actually 3 minus 1.2, right? It's what's left over after you subtract this. So that is actually 1.8 meters. So we have an angle, we know opposite, and we want to know adjacent. So remember, you could label this H, A, and O. So we have opposite, we want adjacent, O and A, that's TOA, so we're going to use tan. So we set up our tan of 8.5 degrees is equal to opposite, which is 1.8, over adjacent, which is our width of the river. Okay, so remember to solve for this, we bring W up, and then tan 8.5 will come down. So to show that faster, we can just swap them. So 1.8 divided by tan of 8.5 degrees. Okay, you need to have the degrees there, okay, to fully communicate your understanding. So then just make sure that your calculator, you're using it properly. Your calculator should be in degree mode. And you go 1.8 divided by tan 8.5 and complete the bracket. Press enter. You should get 12.044 meters. So that means that the lake, or is it a river, is about just over 12 meters wide. So therefore, the river is just over 12 meters wide. Okay, there you go. Okay, that's the first example. Now we'll move on to example 2. All right, this example talks about 2 buildings, okay? This is a very important example. I believe a question like this has been on the exam in the past. So it's possible that you may experience a question like this on the final exam. It's a good question because it really tests your ability to work through a word problem as well as your understanding of SOHCAHTOA. Okay, so make sure you really understand this example, rewatch it if you need to. So you have a video camera mounted on top of a 120-meter tall building. So that is an important number. When the camera tilts down 36 degrees, that should say degrees, a little degrees there. With the horizontal, that should be degrees. With the horizontal, it views the bottom of another building. If it tilts up 47 degrees, it can view the top of the same building. How far apart are the 2 buildings? Okay, so first we have to understand if a camera is tilting up to see the top of the building, then the other building must be taller than 120 meters. So let's draw these 2 buildings. So here's your first building. And notice I'm making it smaller. There's building A. And here's building B. And notice I'm making it bigger because we know the camera tilts up to see the top of the building. So that has to be larger. So what do we know here? What can we label? This one is 120 meters. And we don't know this height. That's what we're going to find in part B. Okay, so there's a camera right here. So if it tilts down 36 degrees. Okay, so how do we draw that? Well, here's how it sees the bottom of the building. You should really use a ruler here. It's kind of hard on this trackpad, but so think about what 36 degrees would be. 36 degrees isn't here. You have to make it 36 degrees with some horizontal. So this here is 36 degrees. Then it sees the bottom. And if it tilts up 47 degrees, it sees the top. So this is 47 degrees here. All right, and because this is a horizontal, that's a right triangle, and this is a right triangle. So they want to figure out how far apart are the two buildings. So that's this width here, which can be represented here on the ground, or it can be this red line here, either one, that's the same one. So we have to figure out how can we answer this question. Well, I would take out this triangle here in the middle because we know that this height here is 120 and we know that this is 36. So I'm just going to redraw that right angle triangle over here, that red one. So this is the width we're trying to find. That's how far apart the buildings are. This is the same as building A. Okay, it's here. They're the same height, so that's 120. And then there we go. Sorry, it's not a very good drawing. This is a right triangle, and this is the angle down, which is 36 degrees. So I know opposite, and I want adjacent, so that's tan. So tan of 36 degrees is equal to opposite, which is 120, over adjacent, which is W. So we find then that W equals 120 divided by tan 36 degrees, which comes out to be approximately 165 meters. So therefore, you can write a nice sentence. The buildings are about 165 meters apart. But now they want to find out how tall the second building is. How tall is this building? Well, let's think about how we can answer this question. Okay, notice that we already know from here to here is 120. So really, if we just find this height, we'll call that H, and add it to 120, we can find the height of building B. So I'm going to extract this triangle here, because now we know that W is 165. So we can use this side length and this angle to find this unknown height. So I'm going to redraw that triangle. I just like redrawing the right angle triangles just because it helps me visualize what I'm actually finding. So there's the height I'm trying to find. I know this is 165, and I know that this is 47 degrees. So I'm using tan again. So my tan of 47 degrees equals opposite, which is H, over adjacent, which is 165. So H is equal to 165 times tan of 47 degrees, since I am just multiplying both sides by 165. So you put that in your calculator and you get approximately 177. So be careful, that's not the final answer. Remember, that's just the height of how big this is above the building. So I have to add that to the 120 to get the total height of the building. So height equals 120 plus 177, which equals 297 meters. So you can make a nice therefore statement. Therefore, the second building is 297 meters high. Okay, here we go, our final example, example 3. Yeah, that's our last example. Okay, so a communications antenna is attached to the roof of a school and held in place with 2 guy wires. Okay, so let's visualize this first. So here's the roof of the school, and here is the antenna. Okay, so we assume that that makes a 90-degree angle. It's straight up. Okay, so it's attached with what we call guy wires. So they look like this, straight down. Okay, and they are 16 meters. That's what we were told. And the antenna itself is 12.5 meters tall. So 12.5 meters tall. Okay, this antenna. At what angle do the wires make with the roof? Okay, so here's the wires, here's the roof, so it's this angle we're trying to find. So it will be the same angle in both cases because you can see this is an isosceles triangle. So this angle and this angle will be the same. So we only need to find one of them. So this is the angle we want. So this is our hypotenuse, this is our opposite, and this is our adjacent. So notice that we are given opposite and hypotenuse. So O and H, that goes together with sine. So sine of theta equals opposite, which is 12.5, divided by hypotenuse, which is 16. So remember, we put theta equals the inverse sine, so sine to the negative 1 of 12.5 over 16. Okay, so we put that in our calculator. So you press the second button, sine, and then 12.5 divided by 16. You end the bracket, and you get 51.3751671 degrees. So we will round that to 51 degrees. You can always round to the nearest angle unless I tell you otherwise. Okay, you can put a nice little therefore statement. So therefore, each wire makes a 51-degree angle to the roof. Okay, at what distance from the base of the tower should the wires be secured to the roof? So that's talking about this distance here, which we identified is adjacent to our angle. So we actually have two options here. We can use Pythagorean theorem. Since we know this is 12.5, we know this is 16. So to find the unknown side length, we can use Pythagorean theorem. Or since we now have this angle, we can use SOHCAHTOA. Okay, it's really up to you guys what you want to use. I'll show you both though. So I could use cos here because I want my adjacent and I know my hypotenuse. Okay, so we can say cos of theta, cos 51 degrees equals adjacent, so A, that's what we want to know, over hypotenuse, which is 16. So A equals, pushing button, 16 times cos 51 degrees. So that gives you about 10 meters. Okay, likewise, I could set up Pythagorean theorem. So 12.5 squared plus A squared equals 16 squared. Remember, the number that it equals has to be the hypotenuse. So A squared equals 16 squared minus 12.5 squared. So A squared is equal to about 100, so then A is equal to approximately 10 there as well. So your final answer would be, therefore, the wire should be secured about 10 meters from the base of the antenna. So make sure you're actually answering the question that's being asked. So you don't have to show me both of those methods, you just need one of them. So in order to be successful on this homework, you need to be able to draw an accurate sketch using the given information. Once the sketch is drawn, reread the description to ensure that you have drawn it accurately. You need to be able to identify and label the unknown information and determine the correct, that shouldn't say sine ratio, that should just say the correct trig ratio needed. So sine, cos, or tan. Then use algebra in your calculator to solve and reflect on your solution to make sure it's reasonable in the context. So for this example back here, 10 meters makes sense because it's less than 16 meters. It has to be less than the hypotenuse, but it's still like within the range of how big these numbers are. If it was, like 1 meter, you would think that doesn't make sense. If it was only 1 meter, then this angle would have to be way higher than 51 degrees. Okay, so that's solving problems in the real world with right angled triangles. Thanks for watching. Hope you learned lots.